Hi, everyone. Thank you very much for the introduction. So today, we're going to talk a little bit about the blazing fast data streaming from Magento database for catalog data. And it's going to be very interesting for you to come after this talk with a little bit different perspective on PHP and how PHP and MySQL can work together. So let's start with that. I forgot to turn off my clicker, so let's hope now it works. It's a little bit of a delay. So first of all, about me, I'm passionate about open source, so you probably already learned about it a little bit from my panel this morning. I'm an expert in optimizing web applications, not only Magento. I also did a couple of projects myself where I had to optimize Java applications to reduce number of database queries per minute from a couple of millions to, let's say, 10,000 for large customers. I'm one of grandparents. I wouldn't say myself as only the grandparent. We had like 5 grandparents of Magento originally, so I was in a team of 5. And another thing that I'm very experienced in firefighting of production issues. So this is kind of a skill. I don't like putting out fires in productions, but I have to, right? Because a lot of times merchants come to me when their project just doesn't work out with performance. So question is, like, why do we want to have something blazing fast, right? Can't we just make it just fast? Or slow, maybe? So why do we have to have a blazing fast website? First of all, it's a competitive advantage. So as soon as you can get data from your store and export it somewhere else very fast, you are much more faster to bring new sales, to update prices, to update images of products, to update names and so on. Like as soon as you can have fast export of the data to third-party systems or within Magento itself, you have an advantage because you can quickly manipulate prices, quickly adjust rules, catalog price rules, and so on. Another thing is scalability, right? I know a lot of developers will tell like, hey, we can just throw more servers at it, right? So it's horizontally scalable, but you always will be bottlenecked by the speed of your database. And having blazingly fast exporting functionality itself already gives you much more room for further horizontal scaling, because then you can scale much more than you could scale with the slow system, right? Another one is operational efficiency. So if you have a lot of users in the backend that edit products and so on, if the data is not updated fast enough, there might be some deadlocks happening. Admin users will experience some slowdown in admin panel and so on. Another one is lower infrastructure costs, right? It's good when it's faster and it's also costless. So that's one of the reasons. So where blazing fast data streaming actually helps you the most? First of all, in BI and analytics tools. So as soon as you can export large amounts of data to some BI systems, then you can quickly query the data, build your own reports, and so on. Another one, search and personalization engines, right? If you want to export something, let's say to Adobe Commerce live search, right? You want to have it fast process, not take 5 hours, but you want to have it like in minutes. Here's where fast data streaming can help. Another one is much better data indexation. So we all know horror stories from production where indexers are running for a couple of days on multi-million product data sets. And that's why a lot of people say, okay, we're just gonna move everything to Adobe SaaS solution with a price service or catalog service. But at the same time, you still have this initial sync cost. And I will show you in this presentation how you actually can achieve much more faster performance with just pure PHP and MySQL. Another one is marketplace feeds. How many of you have to export data, let's say to Google Market, to Google Show Feed, or let's say to Amazon Marketplace, and you want to have to do it fast, right? You don't want to sell products on Amazon that are already out of stock in your warehouse, right? You want to quickly get this data through. Oh, so a lot of people would ask, why not use core tools? And one of the things with the core tools, what Magento offers, is excessive memory usage. So Magento uses everything through entity repository, with get list, with collections, and every collection allocates some memory, and it's not really efficient. And it's not only in application itself, it's also on database level, because Magento runs queries that are not memory efficient for MySQL itself. Another thing with core tools, there's 99.9% of redundant I/O operations and CPU usage. So we'll learn a little bit about it. Another thing is how many times Magento has changed API over the last, since, let's say, Magento 2.0 release. Like, how many times, okay, we have to use models, then we have to use entity repositories, then we have to use something different, then we go back again to entity repositories. Like, how many times things change? The way how you have to interact with the data. It's just annoying. But what stays the same is the database schema. How many times Magento changed database schema since 2.0 release? 0, right? I would even say that since Magento 1 release, the general structure of catalog of Magento hasn't changed at all on a database level. So I consider the database of Magento as the most stable API you could ever have. So when you want to quickly export some data from Magento, you want to create some efficient data stream. And by data stream, I mean something that uses prepared statements, something that Magento doesn't do. Magento usually creates an SQL query, sends it as prepared statement to MySQL, but it doesn't reuse that prepared statements later on. So every single time it sends a bunch of string values to MySQL, MySQL parses this data and then returns it back. So what you can do, you can use prepared statements and you can reuse that prepared statements over time. So you can save time on MySQL side on parsing your SQL query. So instead of, let's say, sending every time select from this table where ID in this range, instead of sending that query all the time, you just send the values for value from and from value to. So you only send 16 bytes to MySQL over the network instead of sending to MySQL, let's say, a kilobyte of SQL string. Another thing is range database queries. It's very important to not select with limit offset, because limit offset is very slow on MySQL, because every single time you have adjustment to an offset in SQL query, what happens behind the scenes is that MySQL will still load all the results until that offset to reach the last part of the query. So if you notice in the admin page, let's say you go to the order grid, and if you have million+ records in order grid, and you try to go to the last page, the more you go in a page selector, the slower page becomes, because MySQL have to process all the orders up until that point. So that's why limit offset is very slow on MySQL to retrieve the data. So you can optimize it by using range queries. When you, instead of using limit offset, you just have from this entity ID to this entity ID. So it's much more faster, because then MySQL can take the data directly from the primary key index. And another thing that a lot of developers not aware, but since PHP 7 and PHP 8, PHP is actually faster to merge the data, the complex data of AV structures, than doing it through joins on MySQL side. So sometimes you can use your PHP code to speed things up instead of using MySQL. So one of the important things about range queries, so there is a small story I had with a merchant. The merchant decided, okay, we're going to migrate from Magento 1 to Magento 2, but at the same time, we want to have orders and customers being on Magento 1 and on Magento 2, but for Magento 2, we're going to start all new customers with entity ID plus 1 billion. So we have like between the last customer of Magento 1 till the first customer of Magento 2, we have like 9,900 millions of records of empty data. And if I just increment these values plus 5,000 for this 99 million times of empty data, I will not receive anything. So that's why there is a very nice trick you can use. You can use a group by entity ID, and then you can specify divided by 5,000, and then you will receive a very nice result set from MySQL with all the minimum and maximum entity IDs in that batch size. So you don't need to do anything specific in your PHP application. You don't need to increment entity IDs. You can just have a very simple query to retrieve all the possible ranges for you. Right, so you can specify minimum and maximum, and then you can divide it with a seal by 5,000. Another thing that's very important when you export data from the database is actually executing a join queries, right? So you want to avoid as much as possible joins. And you would use a separate query instead of that. So there's a couple of ways how MySQL executes joins. The perfect one is when you analyze a query, when MySQL shows you index usage. It means that index is being used in order to filter the data from the table. Another one that is not really bad, but also not really good, it's block nested loop. What happens in this case is that MySQL actually puts the table you are joining into RAM because it fits this join buffer size. But the biggest problem there is that it's still, for each record you have in the original table and the one you are joining, it will iterate through every single record of that another table before it finds all the matches. So it doesn't do quick lookups like with indexes. And another one, the worst one possible, is just nested loop. Just nested loop, it's like the previous one was directly in memory, but this one happens on disk. So then it means that MySQL have to read another big file line by line to find all the possible records. So as soon as you have at least 2 left joins in your query, this will happen, especially on large data sets. So that's why I always advocate on reduction of number of join operations in your queries. Even like at the beginning of my career as a software developer, I was thinking like, hey, I can write such nice queries, I can write so many joins, I can do everything in one query. But honestly, with experience, what I've learned that the dumber query is, the better it is for MySQL. Another thing that a lot of people don't know, in PHP, specifically in Magento, all the queries that you try to execute are buffered. So let's say you send the query to MySQL, and PDO library of PHP fetches all the results from the MySQL server, stores it into memory, and then you access it. So it basically stores everything into the memory that you would fetch. So let's say if you have to export, let's say, 1 million records from single query, it means that all of those million records will actually go into PHP memory, which is basically going to be a problem. But what you can do in PHP, you can actually create an unbuffered connection. You can set a flag PDO use buffer query result. You will see it from the proof of concept later in the slides, which you will be able to download. So you create a separate connection. You set this flag do not buffer, but why we create separate connection here? Because as soon as you use unbuffered flag, you cannot execute another query until you fetched the whole result set that was done in previous query. So that's why PDO has this buffering that you can execute multiple queries. It just puts them somewhere in memory so you can just later on access them. But with unbuffered queries, you have to actually process them. So you can use then generators, so you can execute multiple queries from multiple connections, and you can use generators to go through the result set, so you don't put much data into memory. You process data as you go. And another thing, you interleave data between multiple generators. So let's say you fetch one data from main product entity and another data from the EAV records. And then when you sort the result set by entity ID in ascending order, what you can do, you can say, hey, here is entity ID, let's say 1, and here is also 1. Hey, it's the same product, so I can return it to the main processing item. Then here, let's say it's entity ID 3, but here's entity ID 2. Hey, entity ID 2 in EAV data I just keep because I need to have entity ID for number 3. And then you kind of like integrate two generators between each other. And this allows you to kind of emulate non-blocking access with very low memory footprint. So let's take a look at the case of Blazingly fast indexer. This is something that we've built back in second week of March in Den Haag during one of my performance trainings. So we decided to rewrite the category product indexer of Magento from scratch. So within 1.5 days, we decided, okay, what will happen if we completely write this indexer with knowing all of these things about ranged queries, prepared statements, unbuffered queries? What can we achieve? So first of all, we need to know what kind of data is in that indexer. First of all, it tells us which anchor categories contain which products. So usually, like, if category is anchor, all products from subcategories in that tree needs to be included into the anchor category record of the index. Another one is inactive categories should disable the whole subtree of child categories. And the last one is disabled products or not visible individually products should be skipped from the index. So what kind of supporting schema I would use for this index initially? First of all, I want to have an information about this category complex structure without having to build complex join operations. So for that reason, I created a separate supporting index with such fields. Category ID and store ID as a primary key. So for each store, we have a list of available categories, so I don't care about these conditions with a pass matching on root category ID or something like that. I just have already all the data needed for this specific store. Another one is anchor IDs. It's actually a JSON array field in MySQL. If you didn't know, in Magento, you actually can specify in DB schema field as JSON, and you can use it quite well because I don't like exploding by comma. I just like to do JSON decode in my PHP code. But I mentioned before that I can order values by entity IDs, but with categories, it's a little bit different. I created a small state machine to make it fast. The state machine for tree of categories works like that. I take all the categories from Magento, ordered by pass in ascending order. And what happens? Magento will have this data returned to you already in a tree manner. So you have first parent category, then you have all the children category in such order. And then you go, again, it's almost like a Christmas tree structure returned from the database. So it's already ordered in the right way. And what happens is that I can maintain a state between each of the items by tracking changes in level. And I can transition to an active state by tracking the level of the current entry. And then if it becomes inactive, I know I have to ignore all the rest of the items in a Christmas tree structure. And when I change the level back up and category becomes active, I can start tracking categories again. And then I can pop anchor IDs if category is anchor by the value. The product part of the index is much more simpler because it just selects main entity of records with generators. Then it selects data for relevant EAV attribute codes, and relevant EAV attribute codes are status and visibility. And then it generates the data based on category lookup because it can join then this lookup table with catalog category product table. and I already have all the data I need for this specific product with which anchor categories this product is assigned to. And then I can use generators to continuously stream data and send it to the indexer. So I run some benchmarks, and here's the reference data for a setup for the benchmark. So it's 1,000 categories, free store views, 260,000 of real SKUs, 5K visible configurable products, and around 30% of those simple products assigned to configurable products are also visible within categories too. So you can also get this data by following this repository. It's a repository I use as a test setup for my performance training. If you'd like to make a photo of a slide. Okay. So how fast it is? How do you think, how long it will take for the core indexer to process all this data? Let's start with single-threaded mode. So the single-threaded mode, it tells like the standard Magento indexer runs in 4.5 minutes, at least. Right, it's one CPU that does all the work and so on. Yeah, it's not bad. It's not slow, but the problem here is that I run it with different data sets. I also have like extra large with 1 million plus products in the database, and that one was already like running for 17 minutes. So the time is quite, increases with data size quite a lot. Then we have multi-threaded execution. You would expect like, okay, I have like 3 store views, so Magento would create like 3 child processes, and it should be like 3 times faster, but no, it's just only like 2 times, not 3 times, because there's a lot of overhead happening. And the new implementations that I've built runs only in 6 seconds, right? This is quite interesting. And another thing, for 1 million plus products, it's not on the slides, but you can run it yourself to test it later with extra large dataset. For extra large database, that's going to be 22 seconds, right? While the core implementation with single thread, 17 minutes, and multi-threaded one is around 10 minutes. So this is a huge difference. And it's just the way how we approach our database queries and how we work with PHP. Because the funny thing about the indexer itself, the most time is spent on PHP side by generating the index structure, not on actually running database queries. Like database queries are very small. If you run a profiler with that indexer, you will see it's very small spans of time spent on MySQL side. So it is faster. But is it blazing fast? Kind of, but in future, we can actually improve things. Because right now, what happens, it happens in sequential order because it's a blocking process. Yeah, I do some interleaving there between the data types, but still, if I want to insert data into store 1 table, I have to wait till the insertion completes before I can insert data into store 2 table and store 3 table. So what can help us here is non-blocking implementation, where we create a couple of PHP processes, and then we do inter-process communication. And let's say from one process, we take the data, and in another background process, we actually store the data into the tables. So you can do that. It's not yet in proof of concept, but it's something that I'm planning to do. You can grab a proof of concept by following this URL. So take it, install it locally, run it, test it on your datasets, compare it with whatever you have in your Magento stores. It's a very rough thing. There's also, in this proof of concept, you can also see some example exporter that also uses the same approaches. The good thing, this indexation approach actually coming to Main.js. So Main.js, we're still like working out the details, but they're basically doing a grant for my work on performance improvements to the indexation and other stuff. So most probably, maybe in a couple of months, we're going to have much more faster indexation for all the indexers, not only whatever proof of concept we have here. Another announcement, on 17th of June, I'm coming to Bucharest to give a 5-day performance training where you can learn about optimizing time to first byte. You can learn how to write this kind of indexation from scratch. And you can also learn how to optimize your varnish setup and how to optimize your caching in Magento with Redis. So like it's full performance knowledge transfer from me to you within 5 days. I had already like 4 trainings done before, one in Poland, one in Barcelona in Spain, one in the Netherlands, and one in Canada. And everyone was very happy, and they changed completely their approach, how they work with database after this training. So I highly advise you to join me on the 17th of June. It's very good price because it's like 1,500 euros for 5 days. I would say it's a steal. So thank you very much.